We've made it to day 4 in our discussion of trig identities. Today's topic is going to be the half-angle formulas. Last video was on double angle formulas, so now we're going to see what happens if we do the cosine or the sine or the tangent of half of an angle, not double it. So last time we did these double angles here in yellow. Today we're going to cover these half angles. And this list is a little bit overdoing it. We need, there are several items here for tangent of half of theta. We need to know definitely what sine and cosine are. And then all of these are just different little varieties of the tangent one. None of them are, they're all identical, so they're all the same thing. It's just a different way to express them. So be aware that there's a ton of different ones listed for tangent, but you're not going to have to memorize them or anything like that. So choose the one that works best for the problem you're working on. So back to today. This one, I don't have a lot of problem examples, so we're going to talk about where some of these come from. I'm going to start with this. This is a double angle from the last video. Cosine of 2a is 2 cosine squared minus 1, which is down here. Cosine 2 theta, 2 cosine squared theta minus 1. I want to start with that again, if we're taking that to be true, then we can work on that and manipulate it to create some new ones. I want to start by moving the 1 over. Whoops, I forgot to move the 1 over. 2 cosine, or cosine of 2a plus 1 equals 2 cosine squared a. And now I'm going to multiply both sides by a half to get rid of the 2. And I want to stop, and this is not one of the identities on the sheet that you are using. And it is in a lot of trig identity sheets. It's a formula for cosine squared. Similarly, we could get a formula for sine squared, which is equal to 1/2 times 1 minus cosine 2a. And I don't like that one being backwards. I'm going to rewrite that one. Cosine squared a is 1/2 times 1 plus cosine 2a. This is a pretty common trig identity because there will be times when you have a cosine squared or a sine squared and you need it not to be squared. And the trade-off is your angle becomes 2a, but I want you to add this on to your identities page. It's in our textbook, the old book. It's listed with the half-angle formulas, but like I said, it's not on your sheet. But these two can be pretty important. And we could have just started with the double angle and rearranged them to isolate sine squared and cosine squared. But I just want you to be aware that they are often written like this. Now, the reason we stop there is I want to use this to come up with the formulas that we see, these half-angle formulas. And I've just copied, by the way, this half-angle section a couple times so I don't have to keep scrolling. Let's focus on the cosine. If cosine squared a is equal to 1/2 times 1 plus cosine 2a, if I were to square root both sides of this equation, cosine a equals plus or minus square root 1/2 times 1 plus cosine 2a. Now this almost looks like this one. All right, I see the 1/2, they have it written as over 2, but that's the same thing, 1 plus cosine of the angle. The difference here is I have an angle A and then it's double under the square root. But think about it, if my angle were theta over 2, wouldn't theta just be its double? Or in other words, whatever angle is here, this needs to be half of it. Whatever angle is here, 2a, this is half of it. So the fact that it's a and 2a versus 1/2 and theta, those are arbitrary angled names. So the important thing is that the angle on the left is half as big as the angle on the right. So using that fact, we get our half-angle formula for cosine. So we'll talk about the plus or minus in just a minute, but that gets us this one. We could do the same thing to get sine, and then the tangent, if you use sine and cosine together and put sine over cosine, you get tangent. And like I said, there's a bunch of different options for the tangent version, depending on what you know and what you need to know. So that's kind of where these half angles come from. So now let's use them to do a common style of question. All right, so this one is about an angle x, and we've seen problems like this from day to day where we don't really know, we don't ever really find out what that angle x is. We just set it up and make a triangle and then use the identities to answer questions about it. So the information I'm given is that the cosine of x is -3/5, and x lives between 180 and 270 degrees. Sometimes it'll just tell you the quadrant, sometimes it'll tell you cosine's negative, sine is positive, or whatever. They'll give you enough information to locate this angle. Always make your angles, by the way. I've seen some of this happening in class. Always make your angles go towards the x-axis. Right? I don't want to draw my angle like, for instance, if it was in the first quadrant like that, I want to make it go down to the x-axis to do my setup. Now, the cosine, which is adjacent over hypotenuse, is -3/5. Okay, and then 3, 4, 5 triangle, as we usually see, a nice Pythagorean triple, leaves us with 4. And that's also negative because I'm going downward. So once again, if it's left or down, put a negative with it, but always make your hypotenuse positive. So here's the angle. I can come up with all 6 trig functions of this angle just using SOHCAHTOA. All right, so the sine is -4/5, the cosine is -3/5, the tangent is 4/3, and so on. I could flip those over for my other 3. I know all the information I need to know about x, but I still don't know how many degrees or radians x is. I just know that what quadrant it's in. All right, so let's get to it. The question is, first, what's sine of half x? So I'm going to start by just writing down my identity. The sine of 1/2 of an angle is plus or minus square root. And you can do 1/2 times 1 minus cosine, or according to our chart, it's 1 minus cosine theta over 2. Same thing. Whether you put it over 2 or 1/2 and then parentheses, that's fine either way. So this is no big deal. I just need to know what the cosine, and I changed from x to theta. I'm going to go back to x. I just need to know what the cosine is. Well, I already know what the cosine is. It's -3/5. So I need to put a -3/5 in there. And this is an expression I can work with. Now, here's the thing that makes these tricky from time to time. Which do I choose, plus or minus? You need to write this down and put a bunch of stars and circles around it. Choose plus or minus based on where 1/2 x terminates. All right, I get a lot of negative or positive answers that aren't quite right because of this rule. So what this means, I need to know whether sine is plus or minus, cosine is plus or minus, and tangent is plus or minus in some cases. That decision is not based on me being over here in the third quadrant. If the angle x is in the third quadrant where sine is negative, cosine is negative, and tangent is positive, but that's not how I choose to use plus or minus. I choose that on where 1/2 x is. I don't know exactly how many degrees x is, but I know that if x is between 180 and 270, half of 180 is 90, half of 270 is 135. So 1/2 x is somewhere between 90 and 135, which is in the second quadrant, which means over here, cosine is negative, less than 0. Sine of half x is positive because it's in the top, greater than 0. And tangent of half x is less than 0 also, because one negative and one positive makes a negative. All right, so that little fact, which is not too complicated, but it's easy to mix up. We are focused on the third quadrant for our setup, but we're not going to choose plus or minus based on the third quadrant. We're going to choose it based on 90 to 135. So anyway, sine of 1/2 x, is it plus or minus? Well, we just talked about it's up on top, so it's positive. All right, that's how I choose the positive. Once that's taken care of, I'm just simplifying. Square root. Let's see, 1 minus negative 3/2. That's a plus, so that's, or excuse me, fifths. That's 8 fifths plus 3 fifths. Excuse me. Slow down. 5 fifths plus 3 fifths is 8 fifths divided by 2. And half of 8 fifths is 4 fifths. And that's sort of an answer, but denominators under square roots are not entirely proper. So let's rationalize that. First of all, the square root of 4 is 2 over the square root of 5. Rationalize 2 square root of 5 over 5. All right, so long story short, the sine of half of this angle that I have a description for is 2 square root of 5 over 5. Positive because that's where 1/2 terminates. Half of x terminates up there. All right, so I'm going to next do cosine and tangent of 1/2 x. I will encourage you to pause this video right now, figure out what cosine of half x and tangent of half x are, and then restart it to confirm your answers. I'm sure you will all take advantage of that recommendation. Cosine of half x is plus or minus 1 plus cosine over 2. Square root 1 plus cosine x over 2. So it's just the same except a plus instead of a minus in terms of 1 minus or 1 plus the cosine. Now the plus minus in the front, again, 90 to 135 is over on the left. We're going to choose minus because 1/2 x terminates on the left side of the coordinate plane. So negative is the sign I choose for the front as opposed to the positive answer I got earlier. Negative square root of 1 plus the cosine of this angle is negative 3 fifths. That was actually the given information a long time ago. And it's the negative 3 fifths I just used in my last part. Okay, so negative square root 5 fifths minus 3 fifths is 2 fifths divided by 2 is 1 fifth. 1 over square root of 5, rationalize square root of 5 over 5. So the cosine of 1/2 x, oh, excuse me, I made a big deal about this negative sign and then I lost it, is negative square root of 5 over 5. And then quickly, use the tangent formula if you please, but never forget this. I wouldn't consider it cheating. I would be proud that you understood this. If we use any one of these 800 different possibilities for tangent of half x, all of those, they're all going to produce the same answer, and they're all going to be the same thing as taking the two answers we just got, 2 square root of 5 over 5, divided by negative square root of 5 over 5, and then simplifying that. Multiply by that fraction flipped over. Cancel, 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 cancel. And unless I'm confused, which I don't believe I am, the whole thing cancels except for a negative sign and a 2. All right, so these, you're used to working with identities. These are some new ones. This statement in green is our most common source of errors, but that's going to do it for half angles. Young out.